All right, so in the last part of our tutorial videos, we are going to learn first about creating functions. So the best way to learn how to create functions in R is to go through an example, and the methodology is almost the same as creating functions in other programming languages. So here we are going to define a function which is going to calculate the circumference and the area of a circle for given radius length. Okay, so we are just going to introduce the radius length, and then the function is going to calculate the circumference of this circle and the area of the circle. Now, we will say that this is a function named as circle, and circle is a function which uses this argument as an input. So you are going to introduce the radius as an argument into this function, and then it is going to return the circumference and the area of that circle. So after that, after defining that circle is a function which takes the argument r as radius, in these curly brackets, we write down the comments, sequence of comments that will perform the necessary operation that the function is supposed to perform. So the first of all, we need to calculate the circumference. And we know that the circumference of a circle is calculated as 2 times pi times the radius length. Okay, so you multiply the radius length with 2 and multiply it with pi, and that is the circumference of the circle. And we then calculate the area of the circle as pi times r squared, the radius square. And finally, we have two values here, the circumference and the area is calculated, and we combine these two values in a vector, and the name of this vector is going to be res. Okay, so here res stands for result of the function, or the response of the function. And after defining the outputs, the circumference and the area as a single vector with two elements, we use another command which is called names, and we say names of res as a vector which contains two elements given in a qualitative format. So you see we have these signs, and in these signs we can write down strings, and these strings are going to be counted as the names of each element in the res vector. So the first element will be named as circumference, and the second element is going to be named as area. Finally, in the last command line, we simply write down res, which is going to print the output vector as a result function. Now, let's copy this function into the R console, and then we are going to run circle tree. And as you can see, this function calculates the circumference and the area of a circle which has the radius length equal to 3. If you do this for 1, you will see the circumference is equal to 2 pi and the area is equal to the number pi. Another function we can create is another simple function. You know, we can calculate the roots of quadratic functions by defining the coefficients. So let's just say, I'm not writing this as a comment, but for you to see, if you have a polynomial in this format, ax squared plus bx plus c, and let's just say this polynomial is equal to 0, and we want to identify the roots for this polynomial. In order to do that, we need to use the discriminant and the quadratic polynomial or quadratic function root formulas. And basically, this function that we are going to create is going to evaluate the quadratic roots of a polynomial for the second order coefficient a, first order coefficient b, and coefficient, the intercept coefficient c. So How do we do that? So we give the arguments into this function. We say that quadratic roots is a function using arguments a, b, and c. Then in the curly brackets, we are going to write down the sequence of commands that this function is going to perform. And in the final line, we are going to write down the response vector that is created. So first we calculate the discriminant. The discriminant is equal to b squared minus 4ac. And the result is, in parentheses, in the numerator, we write minus b plus and minus square root of the discriminant. So you remember in the formulation, we have minus b plus minus the square root of the discriminant. And here I write a vector which consists of two elements where we have minus and plus 1 in each respective element. Therefore, if you multiply the square root of the discriminant with this vector, then you are going to get a vector with a negative square root and a positive square root of the discriminant. And if you sum these values with minus b, again, minus b is going to repeat it twice. So the shorter vector is going to come to the length of the longer vector. And you are going to see two results here. Finally, when you divide the overall to 2, you are going to get the roots of this polynomial. And finally, these roots will be printed in the last command line. So let's see here. We would like to identify the quadratic roots of a polynomial with a being equal to 1, b being equal to 1 again, and c being equal to 1, let's just say, and the roots will be non-available in this case. Okay, why? Because, I mean, we do not have any real roots for this polynomial. And if we do that for 1 to 1, then you will see we have quadratic roots which are equal to each other. So we have a single root basically, that is minus 1 to solve this quadratic equation. And if we do that for other values, for example, where a is equal to 1, b is equal to 2, and c is equal to minus 3, we have two roots of this polynomial, which is minus 3 and 1. Okay, so this is how we can create functions, and actually in our future courses we are going to learn even more about creating functions. Now we are going to learn how to define loops and how to print text. And you see we have the maximum of two vectors defined as a function. We have y1 and y2, two vectors. Actually, we know how to calculate the piecewise maximum of two vectors, y1 and y2. We can simply use the pmax function if you remember. Okay. However, this time we are going to write down another function which does the same thing as the pmax function, however, over a for loop. So it is going to give us the piecewise maximum of two vectors. That is going to be a function, and we are going to give two vectors into this function arguments. And then in this curly brackets, it is going to perform the operations that it is supposed to perform. The first thing that it should do is to compare the lengths of these vectors, because if the lengths of these vectors do not match, then we cannot make a piecewise comparison. So we start with an if statement. We will say that if the length of the first vector is not equal to the length of the second vector, then in square brackets, we say that print the warning, the lengths of the vectors are different. After closing the curly bracket, we write else. What is the else condition? The else condition is the condition where the length of both vectors are the same. In the else condition, we write down another curly bracket here, and we say the length of y1 is assigned to n. So n is defined as the length of these vectors. And we define a result vector, initialize a result vector as 0. So in the beginning, we initialize it as 0. Then we start a for loop. And we say that for the index I taking values in a vector of integers from 1 to n. So I in integers from 1 to n. So I is going to take values in this vector one by one. In this for loop, I is going to change its value to every value one by one in this vector. Then after defining the for loop index, we open again another curly bracket and we say the ith index of the result vector, so it is going to start from the first index until the nth index, is going to be equal to the maximum of the ith index of y1 and the ith index of y2. So we are making a piecewise comparison of two vectors in each index and record it into the ith index of the result vector. Once the for loop is complete for all indices, the function is going to print the rest vector. Now let's perform this function. So this function is defined right now. I am just going to define a vector y1 as 1 to 10 and y2 as 8 to 1. So the lengths of these two vectors are different right now. And let's check max to wake function for these two vectors, y1 and y2. So we get the warning, the lengths of the vectors are different. Now, if I change y2 to 10 to 1, now lengths will match. If I run this function once again, you see we have y1 here, y2 here, and actually max to wake function returns us the piecewise maximum of both functions in a for loop. And for each index, we get the component-wise maximum. Now, remember, you could have also done this in a single comment line. Okay, so you get the same result as the Pmax function, but this time, instead of using a built-in function, you defined your own function to do that. Okay, now I would like to show a few easier things to scan data. So let's just say you have a data which is stored in a column of an Excel file or in a text file where we have a blank space between every consecutive value, or the consecutive value is written in the next line. Okay, so we have these kind of data. So what I'm going to do is this: I'm going to store these values in a vector. So how many values do I see here? In the first row, we have 4 values. In the second row, we have 3. So that makes 7, 9, 11, 13, 14, and 15. We have 15 values here. We would like to store these values into a single vector, which is named as x. So what I'm going to do is this: x, I'm just going to define x, and I will say scan. So after doing this operation, the previous stored values over x will be overwritten. They are not going to exist anymore. So I say x is equal to the scanned values. I say scan. And when I press enter, it asks me to enter the first value that I am supposed to enter. So either I can enter value one by one like this. So then after pressing enter, it is going to ask me what is the second value. I can enter the second value, third value, so on and so forth. So let's just say I'm just going to stop here. I'm not going to assign any fourth value. So x is just going to be a vector of length 3 containing the values of 3, 4, 7. So I do not enter anything to the fourth index, and I press enter once again. And it says I have read 3 items. Now x is a vector that contains these 3 values, 3, 4, 7. Now, instead of writing the values one by one, if I copy my values from this text file and simply paste them here, you see it reads 4 values in the first line, and the fifth value is 547. it reads other two values in the second line, and it reads the 8th value. So you see every value separated with a blank space or in a new line is counted as a new value, and it asks me, once I press enter, it asks me to enter the 16th value. However, I do not have any 16th value. I press enter again. Therefore, it says I have read 15 items, and when I print X again, it is going to be a vector of size 15 containing the values I have copied in this text file. Okay, so this is how you can transfer a row or a column of data in Excel. You can also do it with Excel. So let me show that to you. I can have an Excel file here. It is just going to take a little while to do that. And so let's just say I have a few values that I have created here, and I am just going to copy these values. Okay, so these are just arbitrary values that I have created. I am copying these values here, and I go back to my R session and I say y is scan, open and close parentheses, and I use Control Control V command to paste every value that I have copied from Excel. So you can basically transfer a column of data to our environment with that simple operation. Now your values are stored in a vector in Y variable. Okay. So my friends, let me show you in the end of this video, let me show you have seen many things. Now you may think what we are going to do with these too many information. So we have learned too many comments here. We have learned too many things. However, each of them is going to be useful in your future studies in industrial engineering. I totally recommend you to learn at least one high-level programming language, either R or Python or MATLAB. It does not matter which one you use. However, in your industrial engineering education, I suppose you need to implement everything that you learned in any course in programming environments. And these high-level programming languages, they provide you a nice practical area to implement your algorithms that you have learned in the theoretical courses. So we are going to do the probability class. It is best if you repeat the practices that you have seen in this video by studying the, let me show that in this folder, the R tutorial file that I have prepared for you. And it is here. So we have these sections explaining everything one by one, which I have not, and some of which I have not explained in these videos. You can read this R tutorial file, practice the commands to understand them better, and you can come prepared to the next week's classes. All right, I'm just going to stop recording right now. Have fun with the R tutorial.